Have you heard of Keepsake? Well, neither had I, until someone reached out to say that this obscure 2006 point-and-click adventure game had issues with crashing. Now the game is clearly important to someone, so let's see if we can fix it. It costs less than £1 on Steam, so let's fire it up and have a look. I appreciate the ability to start it in windowed mode, as it makes running it under a debugger a lot easier. I've just played for a little bit and the whole beginning of the game is a real fever dream, so let me share my experience with you. I nailed the first puzzle to open up the school. I walked around the school, but all the doors were locked.
Darn, this door is locked.
This door is locked. I'll need a key to open this door. Without a key, I won't go any further.
I gave up and asked for a hint, which said that despite opening the school, I needed to first explore the forest. I found a merchant who was lamenting that he's not allowed around the school unaccompanied, which is not at all concerning. I rescued a dog who thinks he's a dragon.
My name is Zach. I'm a mighty dragon.
I watched a cutscene where two men dressed as children exchanged gifts.
I, Lydia, swear to remember.
And then out of
I
nowhere,
wonder what these
harpsichord.
strange machines are.
After talking with a chap on Discord, he provided a save file which takes us straight to the crash, and sure enough, if we keep taking this lower right path in the maze, then eventually we crash with this pop-up. This looks strange, with a stack trace suggesting the issue is in some Steam library being called from malloc. And also something about a free list. So my assumption here is some memory corruption. If we open the game executable in Ghidra, then it's just a simple loader for a DLL called Keepsake DLL. So let's get that loaded into Ghidra. The function it actually crashes in is huge, and some strings suggest it's handling walking. The question is, does the function cause the memory corruption, or is it already knackered when we enter? It's hard to say as it's called from lots of places. It's weird, when I have the debugger attached, I don't get that pop-up and the crash seems unrelated. I've searched for the assert string in the accompanying engine.dll and set a breakpoint on all occurrences, but it's never hit. Neither is the assert in MSVC. Okay, so now I've run the game till it crashes and then attached the debugger, and the assert is from frustviz.dll and the stack comes from exit process. I suspect the game has crashed, raised an unhandled exception, and the game is now running through its exit handlers, but as the game is in some weird unknown state, it's no wonder that this assert is failing. Yes, in fact, we can see the function being registered with @exit here in frustviz.dll. Basically, the pop-up is a red herring. It's a symptom of the crash, not the actual cause. We really need to understand why the original crash is happening. The crashing function seems to be called twice, once when you click to set a new target for the player, and again when the player reaches that target and triggers a new screen to load. I'm trying to divine some difference between the two. We know at the point of the crash the result of EDX plus EAX times 4 is massive. And if we trace through the assembly, we can see 4 places where the calculation could go wrong. This is pretty painful, but I've been slowly grinding it out. Eventually ECX, which holds the C++ this pointer for the class, is null, but it's not null when the function is called. Here we're calculating some sort of offset into heap allocated memory, and if we follow that, we get a bunch of constants, which I think is used for iterating through a loop. So maybe we're running off the end of this? Taking a small step back, the crash happens in this double loop. I think we just need to patch in some extra null pointer checks for these variables. There's several ways to patch a binary, and I've opted for DLL hijacking. When Windows loads your executable, it will also load all the libraries that it needs, but it will first check to see if they exist in the local directory before reaching out to the system files. If we look at the game, we can see it uses ddraw.dll, and from that, it only uses one function. So if we create a DLL with the same name, which exposes the same function, then Windows will happily load this for us. If we then load the real version from the system files, we can proxy any calls to the real DLL and execute any code we want in the process. My little ddraw.dll also allocates some read-write executable memory, into which I copy a small amount of handcrafted artisanal assembly. I then patch the loop to jump to this code, where it does some null pointer checks and either jumps back into the loop or after it. It sort of works, although there's now some weird graphical glitch. And by sort of works, I mean it doesn't work, because apparently it crashes in another part of the game which has the same issue. So I've got another save file which allows me to trigger the bug somewhere else in the game, and the dog who thinks he's a dragon is now a cat? Interestingly, we don't get null values here but other random ones, so there's clearly something else at play. I've done some more logging and tracing, and it looks like the bad value comes from here, which is calculating some offset from the this pointer. But do we have a bad pointer, or just a pointer to bad data? Luckily ECX is the same every time, so we can set a hardware breakpoint to see what's setting it. It's hit here, which is some cleanup code, calling delete and setting to 0, and it's also set from a new call here. Both of these functions are called from that massive function. I think I just really need to figure out what this is doing. Luckily, I've not had to look far. There's a log line at the start which I missed before saying that the file is called a*search.h. A* is a classic search algorithm and is probably what the game is using to calculate the path the player must walk to the mouse click location. I'm no expert, but I took a guess at what some of these members are based on my understanding of the algorithm. I even tried asking an LLM and it enthusiastically agreed with everything I was saying. Taking a slightly higher level look at things, this magic number stands out. It looks like it's resetting some state based on a counter, and it does this before the algorithm starts. I'm not sure what the purpose of the counter is, but there's other fields in this class it probably wants to 0 as well. So back to the patch. Let's make this run every iteration and also reset some of the other fields we know the algorithm uses. And it looks like it works. Package it up, sent it over, and we think the issue is fixed. In our discourse, he also mentioned that the issue doesn't present itself in the CD version, so I've bought myself one off eBay. The DLLs do have different hashes and different strings inside, and it looks like there was a specific build for Steam. Interestingly, the CD version was linked against the debug version of the MSVC runtime. This normally fills uninitialized dynamically allocated memory with a known pattern, so maybe this was enough to not trigger the bug. After fixing it, I posted it as a community challenge to Discord to see how other people might tackle this problem. So congratulations to OXC0000005, an apt username. They saw the difference in the versions of the MSVC DLL and patched the Steam one to use the debug version. This fixed the issue and is a nice approach. We're hoping to run a new community challenge soon, so do drop by the Discord. However, during the fix for another game, I had to defeat an old school DRM, so to see that, check out this next video.